Hello and welcome to 8.2 Notes. First off, let's review what a parallelogram is. Okay, so this is a parallelogram, and the definition of a parallelogram is that it's a quadrilateral, so it's a four-sided figure, a quadrilateral with both pairs of opposite sides being parallel. So this side is parallel to this side, and this side is parallel to that side. And that, my fine students, is a parallelogram. Okay, so today's notes is going to be regarding properties of parallelograms, and the first one is this first theorem is if a quadrilateral is a parallelogram, then its opposite sides are congruent. So if you have a parallelogram, then its opposite sides are congruent. This will be congruent to this, and this will be congruent to that. So not only parallel to, but also congruent. Okay, so if in this case parallelogram PQRS, if it's a parallelogram, then line segment PQ is congruent with line segment RS, and line segment QR is congruent with line segment PS. And then the next theorem we have is if a quadrilateral is a parallelogram, then its opposite angles are congruent. So here you have a parallelogram, and it's saying that the opposite angles are congruent. Angle R is going to equal angle P, and angle Q is going to equal angle S. Okay? So if PQRS is a parallelogram, then angle P is congruent to angle R, and angle Q is congruent to angle S. Okay? Okay, and here's a typical problem that you would get in this parallelogram. Find FG, the measure of FG, and the measure of angle H. Well, we know that, well, let's go on with the answer. So we know that if we're working with the angle first here, we know that if a quadrilateral is a parallelogram, then its opposite angles are congruent. So the measure of angle F is going to equal the measure of angle H. And the measure of angle F is 60 degrees, so the measure of angle H is 60 degrees as well. And then moving on to find the measure of FG, we have, if a quadrilateral is a parallelogram, then its opposite sides are congruent, right? So this length, FG, is going to equal this length of EH. And we know that EH is 8, so we can substitute EH as 8. And the measure of FG equals the measure of EH, and so the measure of FG equals 8 as well. Okay? All right, moving right along. We have the next theorem here. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So we have this parallelogram, and if PQRS is a parallelogram, then X degrees plus Y degrees equals 180. Okay, these are consecutive angles. Consecutive means right next to each other, and they will total 180 degrees. Okay, you can kind of even sort of consider this two parallel lines, right? We have the chevron, so these are two parallel lines cut by a transversal. And if you remember, the consecutive interior angles theorem states that if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles formed are supplementary. So these angles are supplementary. So it's kind of based on that. Either way, you need to memorize them. You just do have to have an appreciation and understanding that the two next door neighbor angles are going to be supplementary. Those two are supplementary. These two are supplementary. My voice recording went off for some reason, so going back, these two are supplementary because they're consecutive angles. They're right next to each other. These two are supplementary. These two are supplementary. And these two are supplementary as well. Okay? So that's what that theorem means. And then moving right along, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So this diagonal QS, for example, is bisected such that QM is equal to SM. Okay, this length equals this length. The whole entire diagonal is cut in half. And the same is true for the diagonal PR. So we have line segment QM is congruent with line segment SM, and line segment PM is congruent with line segment RM. Okay? Moving right along. Okay, so here's a typical problem you'll get. Find the indicated measure in parallelogram JKLM. So letter A, we need to find the measure of NM. Letter B, we need to find the measure of KM. Letter C, we need to find the measure of angle JML. And letter D, we need to find the measure of angle KML. So let's start off with letter A, the measure of angle NM. Okay, so we have that the measure of NM is equal to the measure of NK, right? Because it states that, the theorem that we had states that if a quadrilateral is a parallelogram, then its diagonals bisect each other. So KM is a diagonal, and therefore NM is equal to NK. Okay? And then, by substitution, we know that NK is 2 units long, so NM equals 2. Okay, we can move right along now. And working with letter B up next, we have that KM is equal to 2NK. Remember that diagonals bisect each other, so KM is equal to 2 of the measures of NK. We know that NK is 2, so 2 times 2 is 4. So KM is 4. All right, moving right along to letter C. We have that the measure of angle KJM, this angle KJM, is equal to the measure of angle KLM, right? Because if a quadrilateral is a parallelogram, then its opposite angles are congruent. So this whole entire angle must equal that whole entire angle. And we have, or we know it's given, that KJM is 110 degrees. So by substitution, we plug in 110 degrees for angle KJM. And so the measure of angle KLM, right here, this must also be 110 degrees. Okay? And we know that the sum of the measures of the interior angles inside of this quadrilateral, right? It's a four-sided figure, so in a sense it's a fourgon. 4 minus 2 is 2. 2 times 180 is 360. So we know the sum of the interior angles inside of this quadrilateral is 360. So we take the total, and we subtract this 110 and this 110, and we get that the two remaining angles must total 140 degrees. Okay? So the measure of angle JKL plus the measure of angle JML must be 140 degrees. But again, if a quadrilateral is a parallelogram, then its opposite angles are congruent, right? So this angle has to equal that angle. So we can write that 2 times the measure of angle JML is equal to 140 degrees, right? Because JKL is equal to JML. So by substitution, we can just say then 2 times JML is equal to 140 degrees, and then we divide both sides by 2 and get that the measure of angle JML equals 70 degrees. Okay? And then finally, moving on to letter D, we have that the measure of angle KML, okay, is equal to, so KML would be this angle here, is equal to JML, the kind of the large angle that could be called angle M if it wasn't for this diagonal, right? If it wasn't for the diagonal KM, we can call this angle M. So JML is the large angle minus JMK, minus this angle that's given to us as being 30 degrees, right? Makes sense? So this portion is equal to the whole thing minus the other side or the other portion of the angle. Okay, so moving right along, substituting in values, we already figured out that JML is 70 degrees, so 70 degrees minus the given 30 degrees, and you get 40 degrees. So the measure of angle KML is 40 degrees. Okay, so that's the end of the notes. If you have any questions or concerns, please feel free to contact me at your convenience, and it would be my pleasure to help you. Okay, bye-bye.